Basically, here, this problem, right?
Yeah.
Okay, it says a set of N people participate in an online video basketball tournament. Each person may be a member of any number of 5-player teams, but no teams may have exactly the same 5 members. Okay, so we have N people, team members 1, 2, for example, T. Each of them is connected to 5, 1, 2, 3, 4, 5, and no teams may have exactly the same 5 members. The site statistics show how previous fact the average over all subsets of size 9 of the set of n participants of the number of complete teams whose members are among those entities stroke of the average over. On this part, let's see, it means what? Over all subset of size 8 of the set of these of the number of complete teams whose members are among these 8. So how many? Okay, let's understand this 9 the average over all subsets of size 9 of the set of n participants
Yeah.
of the
I don't get these
number of
sentences.
complete teams whose members are among those 9 people. Okay, so it says the average. So for each 9 elements here, you should see how many teams are connected to all these 9, right? So
Yeah.
let's see here, from here to this part, this red part. How can we write it in terms of n? In terms of n and t, for example.
I'm not sure because I don't get this.
So it is double counting. So look, it says, for example, we can say all 9 people here. 1 to 9, then 1, 2, 3, 8, 10, right? 1, 2, 3, for example, 8, 11, right? All the way to, for example, n minus. It will be n minus, because 9, n minus 8, n minus 7, all the way to n, right? And for each of them, do you agree? We see, okay, how many teams, all 5 members? For example, we calculate the teams that all 5 members are among these people, right? So, for example, you say it is A1, A2, last one is A what? A sub what?
A's of and choose 9.
Exactly. And now can you tell me the average in terms of AI is what?
Wait, I don't get what it says average. The average of what?
So look, the average of these. Here, for example, we have 2 teams that all members are among these 9 people, okay? We have 2 teams. So you say A1 is 2. A2, for example, is 0. A3 is 4. So you add all of them and divide by number of them, it will be the average. Understood?
Yeah. Okay.
Okay, so the average will be what here? Average 1.
A1 plus A2 all the way to A9 or n choose 9 divided by n choose 9.
Exactly. And now you can say A1 to AN in terms of T and N. So try to see, can you figure out it is what in terms of T and N?
What is T equal to?
Number of teams. The problem says number of teams or what? It doesn't say, right?
No.
Because we don't know number of teams, so we call it T. Okay?
Oh, is it T times n minus 5 choose 4?
Okay, so can you say it again?
T multiplied by n minus 5 choose 4.
You should multiply by. Let me just, sorry, 1 second.
What is this average number?
Okay. Now, let me write. So the numerator is t times what, choose what?
n minus 5, choose 4.
Exactly.
Divided
Over
by
and
n
choose
choose
9,
9. N choose 9.
right?
Okay. Yep.
Okay, now that you found this, the next one is equal to the reciprocal of the average over all subsets of size 8 of the set of n participants of the number of complete teams. Okay, so the next one is exactly for 8, but you should consider reciprocal of that. And then you can solve it easily. Want hint or want to try the rest on your own?
I'll give it a try.
Okay.
No, I got t is equal to n times n minus 1 times n minus 2 times n minus 3 times n minus 4 over 2 to the 5 times 3 squared times 5 times 7, but I don't know how to solve, like figure out how many values of
Okay, so let's
there are.
check. Here we know that t times n minus 5 choose 4 over n choose 9 is equal to n choose 8 over what?
Over t times n minus 5 choose 3.
Exactly. So we can t squared, we can write this. Okay, so if we simplify t squared times n minus 5 factorial, or let's write this right here. T squared times n minus 5, n minus 6, n minus 7, n minus 8 over 4 factorial times n minus 5, n minus 6, n minus 7 over 3 factorial is equal to n times n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, n minus 7, n minus 8, right? N minus for this one,
Yeah.
for n, you can write until this part, and we can say this whole square times n minus 8, right?
Yeah.
All over 9 factorial. Then you simplify this, right?
Yeah.
N minus 5, n minus 5, we can cancel. N minus 6, n minus 6, n minus 7, these you can cancel. And n minus 8 also, we can cancel these. So t squared is equal to 4 factorial, 3 factorial over 9 factorial times n times n minus 1 times n minus 2 times n minus 3 times n minus 4 whole squared, right? You reach this.
I had an 8 factorial on the denominator, so.
So then you've simplified this, the numerator
Well,
and the denominator.
isn't there an n choose 8? So there should be
And
an 8 factorial.
sorry. We have also 8 factorial, right?
Yeah, and simplify. Yeah.
Okay, and it is exactly the thing you've reached.
Yeah, and I simplified
Okay.
I decomposed the fraction.
Okay, great. So because it is t squared, we can cancel these two, and if you simplify these, 4 factorial is 5, 6, 7, 8. 3
Yeah, I think
factorial is 4,
that's
5,
how you wait.
6, 7, 8, 9, right?
I'm not sure what you're writing here.
Look, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9. So let's simplify. When we want to consider t, we can say 1 over 3, so we use this 8. So for 3, let's do something. Here,
I noticed.
let's prime factorize to make it easier.
Yeah, I prime
So
factorized it.
2, you say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2 to the 10. Times 3, it is the
4,
3, 1,
3 to the
2,
4.
3, 4. 3 to the 4th. For 5, 5 squared, right? For
Yeah.
7, 7 squared, finished, right?
Yeah.
So t is 1 over, or let's write like this, n times n minus 1 times n minus 2 times n minus 3 times n minus 4 over 2 to the 5 times 3 squared times 5 times 7. I agree.
Yeah.
Okay, then what? You've reached until this part?
Yeah, this is what I reached. I don't know how to
Okay,
continue.
so look, pay attention to this one. It is n minus 1, n minus 2, n minus 3, n minus 4. It depends on let's see, a problem wants what? How many values of n from this can be the number of participants. So this one should be integer, right?
Yeah.
We should see for how many n it is integer, right? And let's see the choices. Okay. For how many values of n at least 92,017. Okay. So because look, we have 5 consecutive numbers. We can relate t to what?
Mods. Choose function. What is, I don't know. What are you
We can
asking?
relate it to what? Choose what?
And choose 5.
Yes, but the denominator of n choose 5 is what?
Well, it's n factorial over, or just so 5 factorial in this case.
It is n choose 5 over what?
Wait. Okay, wait, you're confusing me. So over 5, no, it should be times 5 factorial divided by 2 to the 5 times 3 squared times 5 times 7.
Yes. N choose 5, because we have 4 times 2, 8, right? 32 is 4 times 3, right?
What happened to the 5?
Let me check. No. It is over 4.
Why are you dividing?
Because it has denominator, you want to reach this.
Okay, take it one step at a time. Just n choose 5 is n times n minus 1 times n minus 2 times n minus 3 times n minus 4 over 5 factorial.
Over this denominator. But we want to reach this denominator.
I know, but I'm taking it like one step at a time first. So so it's n times n minus 1 times n minus 2 times n minus 3 times n minus 4 is equal to n choose 5 times 5 factorial, right? So that we...
Yes, times 5 factorial over this. Now I want to simplify this one.
I know, but I'm writing it one step at a time.
Okay, so if we write 4 times 8, 32. It is 9, 3, 5, we have 7. Agree?
Yeah.
Well, let's see. We have some denominators. So let's focus on these things. We know 32 divides n times n minus 1 times n minus 2 times n minus 3 times n minus 4, right?
Yeah.
Also, we can say, let me write it for 9, 5, 7. From here, n can be what mod 7?
0, 1, 2, 3, and 4.
For n mod 5 is what? All of them will be okay, always.
Yeah.
Right?
Yeah.
What about this one?
0, 1, 2, 3, 4.
Let's say mod 9. Mod 9.
6, 7. 0, 1, 2, 3, 4, 6, 7.
Look, 0 to 4 is good, obviously. 5 is good because
How's
5, 5 minus 1, 5 minus 2, 3. 5 is bad, right?
Yeah, that's what I said.
6 is good because this one has 1, 3, this one has 1, 3. 7.
7's good.
7 minus 1, 6. 7 minus 4, 3. 7 is good. 8.
Not good.
Not good. Okay, 5 and 8 are bad. So let's write only bad numbers. Here also we can write bad numbers. 5 and 6, right? For
Yeah.
this one, n mod 32 should be what?
Almost. I have to find, just like list out all the residues.
We should check it.
What do you mean? So I look through all of them, you mean?
Yes, because if we calculate them, then we can find n mod what number?
32 times 9 times 5 times 7.
No, not times 5, because for 5 all of them are good, right? We don't need to focus on this,
Okay.
right? So 7 times 9 times 32 is what? 7 times this is what?
Yeah, I'm calculating it. It's 2016.
Yes, 2016, right? So the problem says n is from 9 to 2017, right?
Mm-hmm.
Right?
Yeah.
So each combination is a number from 0 to 2015, right?
2015.
2015, because we should calculate mod 26. Look, for example, if we select 0 here and 1 here and, for example, 2 here, then this combination is exactly a unique number from 1 to 2016. Agreed?
Yeah.
So if we find how many cases do we have, we should only multiply them, and only you should check 1 to 8 to see how many of them are in 1 to 8 and also 2017. Okay?
Okay.
And the agree 1 and 2017 are same.
Yeah.
So because we don't have 1 but we have 2017, so you need to only check 2 to 8 because we don't have these numbers. If these numbers satisfy these, then we should subtract it from number of cases. Okay?
Okay.
So the only thing you should do is now to see how many numbers from 0 to 31 are good. Okay? So
Just
for this
bashing
one,
it.
how many good numbers are there for this one?
5
For this one,
and 7.
so the answer is 5 times 7 times the question mark minus number of cases from 2 to 8. Okay? That satisfied you. Understood?
Yeah.
Okay, so you should now find the question mark. How many cases do we have here? And then find this question mark. You should calculate these 2 question marks, find the answer. Try it.
So I got 557.
557.
Yeah.
This choice D, right? Let me erase this. Let me. Okay, so here for 32, the cases that are good, the 0, 1, 2, 3, 4 are good, right?
Yeah.
5 is good or not?
No.
Because here we have 4, here we have 2, only we have. So 6 is good or not?
No. I don't want to
6,
list out every
6
single one
minus 2,
again.
6 minus. So if you check, tell me the numbers that are good.
What'd you say?
Tell me all numbers that are good 0 to 4. Then next one is what?
0 to 4, then it's 8, 10, 12, 16, 17, 18, 19, 20, 24, 26, 28, 32.
Okay. So 32 is 0, right?
Oh yeah, 32 is 0.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the first question mark is 16, right?
Mm-hmm.
And now we want to see from 2 to 8 how many numbers satisfy these things to subtract. 2, 3, 4, 5, 6, 7, 8. So let's use first this one. N shouldn't be 5 or 8 mod 9. So 5 is bad, 8 is bad, right?
Yeah.
N shouldn't be 5 or 6, so 6 is bad. Now they satisfy these. Then N is 2, 2 is good, 3 is good, 4 is good, 7 is not good. So 3 numbers here satisfy this, right?
Yeah.
So we should subtract 3.
Mm-hmm.
Now 5 times
Wait, so
60, 80, 560 minus 3, 557. You said what?
why don't you need to subtract for 2017? Or do we need to consider the 2017 number itself?
Look here, when we multiply these, it means that from 1 to 2016, we have these numbers that are good, right?
Yeah.
560 from 1 to 2016. Okay?
Yeah.
Okay. But
Wait.
the range of the problem is not 1 to 2016. It says 9 to 2017. Okay?
Mm-hmm.
So 1 is similar to 2017. So that's okay. But from 2 to 8, we don't calculate 2 to
Wait, what do
8.
you mean one? Okay, yeah, one is similar to 2017, but we don't need to consider it.
So let me
Or
look. From 1 to 2016, we have 560 numbers that are good. Agreed here.
yeah, yeah.
But we shouldn't consider this range. Look, let me 1, 2, 3,
So
4, 5.
are you saying you like basically move you turn one into 2017, and you basically don't need to make a change then?
Yes, here. When we have 560 numbers that are good, we agree here also we have 560 numbers that are good.
Is that
Because
oh,
1 is exactly similar to 27.
okay, yeah.
So here we have 270 numbers that are good. But the problem
560.
says consider only from 9 to 2070. We found that 2 is good, 3 is good, 4 is good. So when here we have 560 numbers that are good, here we have 3 less, 557 numbers that are good. Okay?
Okay.
Okay, so the answer. What's your next question?